things. So your phase diagram there is showing you density discrepancies or density differences, density variations between one state or the other state. All right. So very, very good. You want to quickly put in mind the constants that follows for water. You want to take note of the constant that goes in for what they call it, for carbon dioxide in terms of critical points, triple points, and all this thing. But before we do so, this region here is where boiling occurs. So the thing there is that we have two things that are very important. We have boiling points, yes, and then we have normal boiling points. Are you getting it now? So we have boiling points and we have normal boiling points. Boiling points can happen anywhere along this place. Boiling, that is, which is this. Boiling can occur any point between 2 points and CP curve. Are you there now? Along any of this. But the normal boiling point is that one that will occur at 0 degrees Celsius for pure water. And what's the difference? Your normal boiling points must be happening at atmospheric pressure. Yes, it must be happening at atmospheric pressure, your normal standard atmospheric pressure, which is what? 1 atm. That answers something quickly. That answers something. If I told you that this curve here is where boiling occurs, right? And I told you that there's something we call normal boiling, which is that 100 degrees Celsius. And I told you that 100 degrees Celsius one is the one happening at 1 atm. It means that if I change pressure from 1 atm to maybe 0.9 atm, the water will no longer be boiling at temperature of 100. It will shift, right? So what does that tell you? It tells you that the normal boiling point temperature is supposed to be below the pressure now, which is your 1 atm. Is it supposed to be above TP, that is triple point pressure, or lower than triple point pressure? It's supposed to be somewhere above, because you can see the curve is above it. So it means that what? That pressure is supposed to be somewhere around here. I'll just put it a boiling point, which I will just write as ATP, which is 1 atm. I'm giving you a clue here. That's why they used to write acids in JUPEB for OBJ. I'm giving you a clue here now. It means 1 atm is supposed to be somewhere above this, because this is where the curve is. I'm telling you that the normal something has to be somewhere around this curve, right? So it turns out that 1 atm is greater than, 1 atm is greater than your what? Than your triple point pressure. Idea now. So if they ask you in the question, which of the following is triple point of water? This is what they usually do in OBJ. Which of the triple is the triple point of water? They will go and put 3 options that will be greater than 1 atm, and put one option that is less than 1 atm. I get what I'm saying now. So a student now who is knowledgeable, that has been in our lecture, we now remember that yes, triple point was somewhere below atmospheric pressure of 1 atm. So the answer has to be something that is less than 1 atm. You see now, so that's how you actually approach all these kind of questions. And we know that 1 atm now, when you trace it, right, it has to link up with a temperature. Because I told you that's the normal boiling temperature, the one that is at 1 atm. It has to link up with the temperature that is what here. If this is in Kelvin, 100 degrees Celsius, which is how many? 300 and what? 373 Kelvin. That gives you another clue again. Critical, what do they call it? Critical temperature has to be a temperature that is greater than what? 373. While your triple point temperature has to be a temperature that is less than what? 273. So these are reference points. So in summary, I don't want to give you numbers. I'll show you how we are able to remember the positioning of those numbers. Oh, how we know that, oh, this the one of water is 270 something. How we know that, oh, the other one is 0.0. I don't just want to give you numbers so that you can know, oh, this is how the breakdown is. Now, based on the position of 1 atm, you see it was the MVP that helped us to be able to relate this thing now. We know that 1 atm must be along this curve for NBP that is going to be happening at 100 degrees Celsius, like normal boiling point at 100 degrees Celsius, so that we can have a pressure that is at 1. We know that boiling point happens at 1 atm, right? So that's how we know that this 373, which is 100 degrees Celsius, has to link up to the pressure of 1 atm here. And that tells us that what? That PC, for water, we're not dealing with carbon dioxide, for water, PC, that's your, what do you call it? Your critical point pressure, right? Has to be greater than what? 1 atm. You see now, PC has to be greater than 1 atm. Why PT for water has to be what? Less than what? 1 atm. I believe we are learning. Now, what about in temperature side? We can now see that TC, these are references, they call it reference points. TC, is TC greater than 373 or less than 373? TC must be greater than what? 373. So TC is greater than 373 Kelvin, while your TP, am I writing rubbish? TT, that's your triple point temperature, has to be what? Less than, based on NBP, has to be less than 373, has to be less than 373. Scientists, if you have this in mind, then remembering numbers or values should not be much of a problem. So good. Given all these directives now on how to get all these parameters, let's quickly dive into the numbers. So here now, for water is what we're dealing with here, for water, right? So we have triple point temperature, we have triple point pressure, we have critical point temperature. Critical point temperature, how did I note it? Okay, I'm supposed to write PT here. PT. Yes, then we have PC, and then I have which one? PC to TC. All these things are just notations. It's you that will decide the notation you want to use. So TT now. TT is this one that I said is supposed to be lower than 373. So all you just need to do is remove 100 from that number. So that's going to be approximately 273, right? Your 273. 273.16. So you see, it's something you guys usually observe, but I don't know if you've noticed. You know that TT is triple point temperature, right? So the thing there is, I don't know if you've observed that sometimes you see liquid melting, right? It will be melting, you'll be seeing the liquid particles in the melting. At the same time, you'll be seeing some kind of gaseous kind of components there, right? So you'll be seeing the gaseous something coming out while you're still seeing solid. So the three of them are literally happening at the same time. So that's it. You can see, because that point there, that 273 is literally approximately your 0 degrees Celsius, which is usually the freezing point temperature. You get what I'm trying to say? That's it. So here now, that's when you're at this point here, 2 points. If this pressure can reduce further very much to about 0.006 atm, it will now be even more observable. You'll be able to observe the triple point properly. This one is Kelvin. So this parameter here is for which one? It's for your what do you call it? It's for your triple point. So you have triple point 273. You can see it's less than 373. You have your triple point pressure, which is what? Less than 1 atm. You can see 0.006. Like I told you that this thing here are not drawn to scale. You obviously, the difference between 1 to 0.8 is supposed to be a long something, but this is not. It's just, this is how you present it in your exam as well. Scale, you just have to identify it that this place is 0.006. This place here is what? 273.16 approximately. Very, very good. Now, how about if you're looking at what? Your what do you call it? Your critical temperature. Where is your critical temperature? You can see that the guy is actually very, very much higher than what? It's very much higher than your 373. You see that while your pressure is also very much higher than your, what do you call it? Than your 1 atm. So what's that parameter going to be? This one here for the temperature is about 643 or 642 approximately, depending, for your temperature TC. 643 Kelvin. Now, some exam I want to ask you in terms of what? In terms of Celsius. If they ask you in terms of Celsius, all you just have to do is to do what? Is to subtract 100 from the parameter. You get what I'm saying now? To subtract 100 from the what? From the parameter. Once you subtract 100 from the parameter, you get 543. So you have to be very, very, very careful, because sometimes that chart you must look here so that it does not look like what they asked you. That's come out to JUPEB. We're going to analyze the JUPEB question on that very soon in one of our videos. That's come out before where they put degree Celsius here. And when you put that degree Celsius there, some people will still be analyzing with Kelvin. If you're analyzing with Kelvin, you are doing rubbish like that. It's rubbish you are just doing. So you are supposed to be working with what? Kelvin, if it's Kelvin. If it's degree Celsius, you work with degree Celsius. Are you there now? So that is it. If you want to convert, you are just subtracting what? you are just subtracting or adding 273 depending on what they're asking you. Do you get what I'm saying now? So if you are given Kelvin and you want to work in degrees Celsius, you subtract 273. If you are given degrees Celsius and you want to work in Kelvin, you add 273. Very, very simple. Now, let's come to this one. ATM for this one is 218 ATM, much higher than 1 ATM. So it means that at 643 Kelvin and 218 ATM, anything above this, takes this substance into a supercritical fluid state. So that is that for water. Literally, I've said everything you need to know for water. Now we move into carbon dioxide. I can tell you for free that it's not as if you need to know the parameters of carbon dioxide, because carbon dioxide is not the standard what they call it, substance used there in what they call it in phase change. The only thing you wanted to note here in carbon dioxide is the curve, the positive gradient slope that is existing here that was different from that you had here. But nevertheless, just in case they ask you in your exam, you will not say that we did not tell you here graciously in Henry's impact. So here we have carbon dioxide. We look at the TT, because I want you guys to understand something. The exam you are preparing for, there is no limit to what they can ask you. They can ask you anything. They can ask you anything. Anything can come out. Now, if you are dealing with the what they call it, critical points, if you are looking at the critical point, you want to take note of that for the temperature, it's usually around 216 degree, Kelvin. Now, there's something I want to quickly say. For carbon dioxide, you see that for water, the 1 ATM, which is our standard ATM, is greater than what? Is greater than the triple point pressure, right? But for carbon dioxide, that's what we used to use to reference. I'm showing you referencing. For carbon dioxide, 1 ATM is usually lower. 1 ATM is usually somewhere lower than PT. But for water, 1 ATM is greater than PT. You can see that now. So with that there, if they ask you a question, and maybe the question that they asked you, they told you, which of the following is the triple point pressure for carbon dioxide? And you are seeing options that have 0.002 ATM, 0.1 ATM, 2 ATM, 3 ATM. You should know that those any answer that is less than 1 ATM cannot be the answer, because the PT of carbon dioxide is greater than 1 ATM. You get that now? That's one of the important reasons they used to use this tool for case study. Now, the what do you call it? The critical point, this thing there is 5.18 ATM. So that's it. They will come here. So what are we trying to say? We're trying to say that when you are at 5.18 and 216 temperature, it means that carbon dioxide usually exists in the 3 states at equilibrium. They will be at equilibrium existing in the 3 states of matter, and that's very, very key. Now, how about for your critical point? For your critical point, you have 304. For your critical point temperature, you have 304.1 Kelvin, and then when you want to look at the pressure, it's usually around 72.0 ATM. So we have 304.1 Kelvin and 72.0 ATM. It means that at this point here, where we say you have 304 approximately 304.1 K, and critical pressure you can see much higher than this one, 72 ATM. This guy, anything above these 2 points is going to enter supercritical fluid state. And also in this case here, pressure 5.18 ATM and temperature of 216 Kelvin. This guy will be in triple points. And that will be that for that. We have come to the end of this lecture on phase and phase diagram and interconversions. Do well to subscribe to our channel if you haven't, and also click on the notification bell. We'll see you in our next lecture.